calculus in motion.
Alright, what if I told you that all those motion equations that you learned during the past year were all derived using calculus? Now, I see the look on your face right now. It'd be all like, what? Don't worry, I'll explain a bit. Now, it is important to note that the equation that we mainly concern with is the xf equals xi plus vit plus 1/2 at squared, or the 1 second to the top, as you can see. Now, the way that you do this is through a series of integrations that relate several functions together, whether that be acceleration, velocity, or position, one of the three. But in this example, we're going to start off with acceleration. And so on Earth, the acceleration due to gravity is, in meters, is negative 9.8 meters per second squared. Let's just imagine that in this example, it's a coin dropping, and it's accelerating at negative 9.8 meters per second squared. First integration is going to give you the velocity function. So when you integrate it, you get Vt equals negative 9.8t plus c1. This c1 is the initial velocity of the coin, which you can solve by given information, whether at time 0, or in this case, we're going to say it's going to be time 3. Now with information given to us, we see that at time 3 the velocity is equal to 11. So what we do is we plug in the values that we have and solve for c1, or the initial velocity. And after doing this, you get c1 is equal to 40.4. Okay, so we have the velocity function, but we need to know position. So what do? We integrate it. We get s of t equals negative 4.9 t squared plus 40.4t plus c2. You may have guessed it, but this c2 that we're looking for is the initial position. And with given information, like this, at t equals 6, the s of 6 is 25. So we solve for the initial position. And by doing so, when you plug in what we have, you get negative 41 for c2. And now that we have c2, we can rewrite the equation to give us our full position equation. Now this might start to look familiar, right? This is the equation that we saw earlier that we use in physics class. It may be slightly rearranged, but don't be fooled. This equation is the exact same one as this one second to the top. And it's this process that found us this equation. Now, I see your face now. It's like,
That knowledge, though.
But that's what you want. You learn a little bit every day. And in calculus, it never stops. So thank you for watching.